The topic of my research project is the development and the application of bioengineering tools, primarily for the investigation of the human lower urinary tract in health and disease conditions, and secondarily for the design and optimization of medical devices and surgical procedures for the treatment of patients with the most highly prevalent symptoms of the lower urinary tract dysfunctions, mainly related to the storage and voiding phases of micturition, so the urinary incontinence and the difficulty urinating. Actually, the available treatments are under investigations due to high rates of complications and surgical revisions, but until now these investigations have been performed only by clinical perspective. What is missing is the specific analysis of fluidodynamic aspects and mechanical phenomena involved overall in functionality of lower urinary tract. For this reason, the aim is to apply the bioengineering approach to this medical issue through a tight coupling between experimental and computational methods. In the laboratory of mechanics of biological tissues in the Department of Industrial Engineering, I am performing different mechanical tasks on different tissues composing the lower urinary tract. These tissues are harvested from human cadaver donors in accordance to the body donation program of the Institute of Anatomy of the University of Padua. These experimental activities allow the mechanical characterization of biological tissues, mandatory for the definition, identification, and validation of computational structural models of this anatomical tract and also of devices which require the interaction with these tissues. In this sense, computational techniques define the other aspect of the approach. By using finite element analysis software, I am performing in silico simulations of different urodynamic scenarios by varying, for example, the anatomy, the pathological condition, or clinical or surgical instrumentation, with the opportunity of evaluating relevant aspects whose clinical investigation may be otherwise difficult or impossible. For instance, an interesting study regards the mechanical stress and strain fields evaluated within urethral tissue when in interaction with an artificial urinary sphincter for the treatment of urinary incontinence. So, the bottom line is to achieve reliable in silico tools supporting the clinical and surgical practice in the evaluation of the most appropriate solution to be adopted, limiting the ethical task, the economic and time costs involved in ex vivo and in vivo trials. All this to contribute to the improvement of the life quality of patients with lower urinary tract dysfunctions.